So good afternoon, ladies and gentlemen. Thank you very much for coming to my presentation. I also want to thank Anwar for his invitation, and of course organizing committee for organizing such a wonderful conference. So today I would like to give a talk about the position environment in the Caspian region. I will mainly focus on paleoclimate. So the research were carried out with my German colleagues and Austrian colleagues, and we mainly focus on the Shamach region, which is very close to here. So I will give you information about study area, evolution of eastern Paratethys Sea, what's eastern Paratethys Sea, and the provenance of our sediments and paleoclimate. So, Miocene is one of the last, Miocene is the last warmest period in Earth's evolution history. It starts approximately before 23 million years ago and finish 5.3 million years. And during the Miocene time, different geological events happened. The climate fluctuation, uplifting of Alps, and uplift of Crater Caucasus, and etc. Such events influence to the Earth, to the Earth, and the main factors that the main characterization of the Miocene time is change volume of the ice sheet in the Antarctic, and at the end of Miocene the ice sheet was formed in the northern hemisphere. For us, as we studied on the eastern Paratethys, the eastern Paratethys was formed during end of the Eocene, and it was a part of the big Tethys Ocean. And since the Miocene time until Pliocene, the water level in this eastern Paratethys was changed several times, and some lakes forms, some lakes were washed. It's the end of it's the start of the Miocene, and then we can see the middle of Miocene. We can see the water level was down, and we can see during middle Miocene the Caucasus mountains forms, and we can see how this Caspian Sea started form, and how this Caspian Sea between Caspian Basin and Black Sea connection was restricted. So such events influence to our region, and at the end of this Miocene, the Black Sea and Caspian Sea was separated. So now Caspian Sea is a lake present time. This is characterized by a lacustre environment. But we try to study past environment based on geochemistry and mineralogy data. We mainly focus on Perküşkül area, which is very close to Baku. It takes just 1 hour from here, and we took some samples because we took some samples in order to reconstruct the provenance and climate. Because you know the Caspian region, it's surrounded by Russian platform, Greater Caucasus, Lesser Caucasus, here Elbrus mountain, and Turkmenistan area, and the different climate from this continent influenced the sedimentation process in the Caspian Basin. And also Miocene is interesting for us because our oil and gas are mainly formed in the Miocene sediment. So our goal of our research to identify the provenance, because for us it's important to know where from our sediments. And after now the origin, the provenance of the sediments, we can talk about this climate, And also we would like to identify a relation between climate change and water level in the eastern part of the sea. So this is outcrops. It's a very wonderful outcrop. Starts with a pirate. Even you can see some jarosite here and the gypsum carbonate. And it is also is interesting if you takes any sheet of this rocks, you can see some fossils inside, such as fish and other marine animals. So what we did, we analyze, we study different kind of minerals in the sediment. It's one of the imagination of the scan electron microscope, where you can see some minerals like quartz, mectite, feldspatz, kaolinite, illite, and of course we did some geochemical analysis. Based on geochemical analysis, we make such as discrimination diagram, which is very helpful for us. It helps us to understand provenance, what kind of deposits were eroded during Miocene time. And what we found that the main source was the Russian platform. Was Russian platform. Our sediments came from Russian platform into the area, to the Caspian Basin. And the deposits was mainly eroded by Paleo-Volga river system. Of course, we can see some mafic rocks, which suggested us influence of the crater Caucasus, because crater Caucasus was because during the great at the time we can get some uplifting in the Caucasus region, and during this uplifting some sediments came into the basin, and of course some volcanic eruption also influenced to the deposition environment. And after identified the source, we focused on to reconstruct paleoclimate. We again use our geochemistry data, mainly major oxides like aluminium oxide, silicium oxide, titan oxide. And we identified that our climate changed between relatively arid and humid. And in this diagram we can see we calculate chemical index alternation, which indicates how chemical weathering was intensive, because when we have high chemical weathering, it means that climate was humid, and we can see how this climate changed during this Miocene time. So we can see the climate was humid, then was arid, and then again humid, and we can see how the trend decrease, which indicate high aridization of the time. And we can see during this arid time, during the arid time, we can see less influence, less sediments came into the basin, because the river system was not active. But during humid time, we can see high influence of these elements, which indicate high influence of different kind of minerals. So what our studies suggest, our studies showed that the climate was the main factor changing water level in eastern part of the sea, and due to arid climate, water level was down. And at the end of Miocene period, due to climate impact, Caspian Sea and Black Sea was separated. So I have told the conclusion. Thank you for your attention.
Hi, I am a student of BSU, Baku State University, as a master. I'm in environmental student. So I wanted to ask, you may You said that we have to make a balance between environment and mining. How can we use it, and how can we realize it? Because nowadays we understand that with high developing technology and techniques, it's sometimes unreachable. You said that we can just guide the guideline and rules, and we can make it positive. But in real time, it's unbelievable. Just I wanted to ask it.
Why do you think that it's unbelievable?
Because when some mining, activities are going, for example, I'm in landscape environment. Landscape are damaging, and the structure of all the landscaping are damaging. So that's why to rehabilitate one landscape or one landscape structure, it's so too hard, and balancing between environment and mining, I think that.
So, to come back, I showed you 2 examples of bad mining and pollution. I could say that there are 100 of these examples all over the world. But out of there's 100 of these examples of bad mining, but there is another 10,000 examples of mining projects that nothing has happened. Nothing has happened with pollution. Nothing has happened with environmental degradation. When it comes to underground mining, it's easy because you don't see it. When it comes to surface mining, and that's why I mentioned the socio-political environmental aspects of it in the mine planning, if there is something to be mined just outside here that would affect, it would not pollute, but it would affect the visual environmental aspect of the people, it would not be mined. But if you mine it somewhere in the mountain that you don't see it, or in a remote area, then there is no problem. Because, of course, you change the landscape. But after mining, you can transform it again. If I had the time, because it was a restricted time, I would have shown more examples of areas of open pit mines that have been mined, and then they have been reforested, land has been rehabilitated, they're being used now for athletic facilities or as theaters or as warehouses or anything else. So mining does not pollute, but practices do that. If we follow the rules, if we follow the regulations, and that is why we have the regulations, then nothing will happen. And of course, as I said, we would not mine outside here, no. Or we would not make a surface mine. Maybe we would go with an underground mine. In the city of Bochum in Germany, that's a very big city of about 4 million people, the coal mining I referred to was happening 1 kilometer below the surface around the whole city. In Freiberg, which is, you can also ask Anvar, it's a very nice, traditional, beautiful city, the mine openings of the old mine were underground the whole city, but that has not affected the city. When it comes to surface mining, that would be outside of the city, not to the visual view of people. And then it should be rehabilitated. So that is how mining and post-mining should work. Unfortunately, we do have these bad examples. In China, there are lax regulations. There is also illegal mining that in such a big country, they cannot protect, they cannot know, and they cannot see all people that go and illegally mine and pollute the environment. And that is something that we try as mining engineers to improve, and legislators should also try as well.
Thank you.
There's another question over there.
Hi, I am Safar Garash. I am from Baku Engineering University. I don't know exactly if it's related with your specialty with geoscience, but I want to know now, how do scientists find how old the fossils are?
Alvar, would you like to answer that since you have been taught about it?
Yeah, but you could also say that.
Okay, I will say the answer. So there is a magic word that is called radioactivity. Radioactivity is not something only bad. Radioactivity is released as an energy when you have a decay of products in a chain series. We have uranium as the primary product in this chain. Do you know what is the half-life? Because it decays, and it decays to other products, and we use the term half-life in order to say that in that time, half of the product has decayed to other products, and the other products go on. So the half-life of uranium, that is the first product in that category, is 4.47 billion years. Does that number remind you something?
No.
The age of Earth. So approximately we know the age of Earth because we know that uranium was there from the very beginning. So when you have fossils and you can use radioactivity to measure their age, I'm not getting now to technical details, but we can discuss it later if you want, you can see which equilibrium has been reached, so you can calculate approximately the thousands or millions of years that these fossil fuels have been there.
Thank you.
Actually, in underground minings in the tunnels of the radioactive.
Everywhere. You can do it everywhere.
And is it possible to make the last question?
Thank you, Barakas, for great presentation. Actually, I have been in the mining operation when I was in field geophysicist in Tashkent and Chavdar field. I just have questions. As you say that in the mining you dig in deeper and on approximately 1 or 4 kilometers. If, for example, the air and how can I say, the mineral flow is in the same direction, what kind of ventilation do you use?
What kind of?
Ventilation.
So, and it is funny because we had that discussion outside. In 4 kilometers, because of the deeper you go, the temperature is getting higher, and of course you have issues with geomechanics as well and stability, but let's stay with ventilation. So at a depth of 4 kilometers in South Africa right now, without ventilation, the temperature would be about 70 degrees of Celsius. If you crack an egg, it will boil in like a few seconds. So what they do in that specific mine, and that may answer your question, they provide, through the ventilation ducts, they provide ice cubes and cold liquefied air, meaning that they have to not only provide fresh air, they have to provide cool fresh air. The same happens with the coal mines because of the depth and because of the heatness that coal produces itself. So in that case, they have to provide cold air.
Not working? Just they provide for 1 hour or for 1 day or 1 month?
Continuously.
Continuously.
There is an airflow, and each mine, each underground mine, has 2 openings. That could be 2 shafts that connect to each other, or it could be a shaft and an opening. One is the ventilation shaft from which you provide fresh air with the airflow, and this has to go outside from the other opening or openings. So you have to circulate this fresh air the whole time. If that stops, then any mining operation should stop immediately, and people with oxygen and cascades should go in repair what is broken, and keep on going. And that is why I showed that we have monitoring as well. So to keep this system, work as well.
Thank you.
Hello, my name is Nargiz Mamadova. I just want to ask, did you concern on biodiversity in mining process? If it is yes, and how is going this process?
Of course, it's one of the, if you remember the mine cycle, it is one of the parameters that is being considered. And also what Anwar said in his presentation, that you have the environmental impact assessment report in order to evaluate everything. In order, biodiversity, everything, flora, fauna, maybe some rare species that are around people, cultural heritage, everything.
And make it the disabilities around us.
So everything is included. We could not get into details because of the restriction of time, but everything is included. It should be at least included in there.
If in this place have an endangered species, in this process is also continue?
No, I will give you an example of an exploration project in Sweden. They have some critical metals. They found a deposit, and they wanted to mine that deposit. So they started with exploration. They started with the planning. They have spent some money. Actually, they've already spent about 3 million euros. And this stopped because there are some rare species and protected lake in the area that is included in the UNESCO World Heritage Places. So the state of Sweden prohibited the mining company from going on. So the mining project didn't even start.
No, it's okay. American Democratic Party is trying to ban coal mines completely. What do you think about it? Do you think it is wrong, it's right? Does it have time in our era? Does it have still some beneficial factors, or you have to completely close it down?
Any kind of mining, including coal mining.
No, just coal mines.
Yeah, no, but any kind of mining, including coal mining, that is my answer, that it should not be prohibited if it goes by the regulations and if it's efficient economically. In Germany, it was not closed because it is prohibited or it is polluting the environment. It is more, the main reason was because the price was lower than the costs to mine it or to buy it, because we're living in a global economy now. It was cheaper to buy it from other countries than to mine it. So we need coal, we need all these metals, we need all these minerals, we need energy, we need everything for our modern way of life.
Yeah.
But we should mine it with respect to the environment so that we don't pollute the environment.
Thank you.
For your presentation. Okay, our next panel is namely information technology, and I would like to invite here Dr. Ashish Set. Mrs. Emma Kocik. And Mr. Siraj Hasanov.
Okay, good afternoon, everyone. So first of all, I would like to congratulate the organizers for successfully organizing this knowledge-sharing platform for all of us. I would like to thank the organizers to giving me an opportunity to participate in the symposium. Today I will be talking about nature-inspired computing. So in this I will be discussing about the different algorithms which is inspired from the nature, and I'll be focusing mainly on TLBO, that is teaching learning based optimization technique. So nature-inspired computing is basically a science of computing that got inspiration from nature. And it has already been realized that many of the problems can be solved if we look closely to the nature and we observe the behavior of the natural creatures. So when we talk of nature-inspired computing, we talk of nature-based intelligence, we talk of computational intelligence. These are basically mature branches of artificial intelligence. Both of them basically have some common features. For example, if you take any problem, they will mimic our natural system or our natural process that can construct a solution which will be optimal both in terms of quality and also in terms of robustness. So in computational intelligence, you will find that these things are always implicit, like nature-inspired algorithms, fuzzy logic systems, neural networks, AI, support vector machines. So let us talk about the inspiration. We need to understand that every problem comes with a solution. The only thing required is to widen our knowledge. We need to closely look to the nature. So when we talk about the nature-inspired computing or computational intelligence, we talk about the artificial life. So artificial life is something which is a human-made system that possesses some essential properties of life. There is one thing to understand, that with the power of nature and with the efficiency of computers, we can do two kinds of research. We need to understand that how the computational techniques can help us to study biological phenomena, as well as we need to explore that how this biological phenomena can help us to solve computational problem. So if you look at this figure, you can relate that human is actually inspired from nature for a long time. So if you look at this beak of the bird, this gives a very creative engineering design that is used for designing a bullet train. Similarly, you can see here, nature provides us a very effective and a simple solutions. And these designs are itself very scientific. So these are some examples which we can conclude that nature inspires us to come up very innovative designs. And these designs are purely inspired from nature. Now, in nature, we have billions of such designs. They are existing at the level of molecule, they are existing at the level of organism, they are existing at the level of ecosystem, and they are existing there for a very longer age. It's been existing there. The only thing we have to focus and we have to identify that how they are helping us to come up with the solution. Now, nature is not only helping us to come up with the innovative physical design, but if you look to the behavior of the natural creature, like how the ants work, how the birds work, how the bees work, they also guide us to come up with an excellent solution. So let us see how they are helping us. So to understand nature, we need to first see that what are the basic components of nature and how we can use these components to solve our problems that we see in our natural life. So in nature, we have 4 basic components. They are said to be self-optimization, self-healing, self-learning, and self-processing. Self-optimization means every component of nature know how to efficiently use the resources which are available to them. Self-healing means when any of the elements in nature comes into problem, they know how to come out of that. Self-learning and self-processing is a kind of mutual thing that works together. The element of nature learns from the environment, they process it to adapt with the system. So these are the fundamental things that exist in nature, and we need to understand how these properties can be used to solve our hard problems. So in day-to-day life, we deal with optimization problem. Optimization is achieving the best with the available resources while satisfying the constraints. And if you observe, you can find then nature has optimized almost everything. And also in our day-to-day life, we always look for optimization. If you want to go to your office, you are looking for an optimal route so that you can reach in a minimum time. If you look at the routers want to deliver the packet in the minimum time from the source to destination. And efficient machines want to process all the tasks in the optimal way. So optimization is everywhere. So the thing is, the more you understand the problem, you will be able to understand how the optimization is applicable. So what is the goal of optimization? So when we talk of optimization, we talk of maximizing, we talk of minimizing. That means we must have some maximizing function, we have some minimizing function, and the goal of optimization, we can say mathematically that we are looking for a variable whose value can either maximize or minimize these objective function. So we have different kind of objective functions are there, and the complexity depends on number of objective in hands. So there are single objective functions, there are multiple objective functions, and we have many different techniques are available to solve these objective functions. We are calling it a traditional approach. Though they are very straightforward, we can find a solution, but then we will find that there are certain problems exist. We call it a hard problem that cannot be solved using these techniques. Because if we try to apply these techniques, you may find that running time is too high. The computation complexity becomes too high. If you are familiar about the algorithm background, if you talk about the 8 queens problem, traveling cell problem, these are said to be NP hard problems because we cannot apply the direct technique here. And even to solve this kind of problem, it may take like 100 years or 200 years with the use of efficient computers. So we have a different approach that is inspired from the nature, that is called stochastic. So in the deterministic way, we have a defined data set, and when you do iterations, you are using the same design parameters, the same function values. But when we talk of stochastic methods, these includes randomness. Randomness in the population, randomness in the strategy. So all these techniques which I have shown here, these are derived from the different phenomena that exist in nature. And they are very much efficient to solve many of the hard problems which are assumed to be highly complex. These are the names of some of the techniques which have already been used in many of the problem solving. So out of these, I'll just give you an idea of ant colony optimization, that how this technique is help us to solve the problem, so that you can have an idea that how the nature is helping us to solve different problems. And then I will show you that how the TLBO is actually used for optimization problems. So ant colony optimization. This is also one of the widely used algorithm for solving the optimization problem. And here, the term I am using is swarm intelligence. Swarm means group. So here the group intelligence is used to solve the problem. So we have a category of problem where the population is working together to come up with the solution. So ant colony optimization is also comes in this category where all the ants are working together. They are working collectively to come up with the solution. So the problem here is ants want to search the food. If you look at the ants are very weak creatures. They don't have very good visible power. They don't have any good communication power. But still, they are doing excellent job because nature has given something to them. So we got some very interesting result out of the two ant properties. This is called stigmergy and foraging. Foraging is an act of searching the food, and stigmergy is a act of indirect coordination through the environment between the two agents or the two actions. What actually is happening here? When the ant starts searching the food, they have no idea where the food is existing. What they are doing, they are leaving some traces, some marks when they search the food. They are leaving some chemical compound, and that is called pheromone. And this pheromone is actually evaporates over a period of time. When the ants search the food, they leave this chemical compound, and it's a kind of help to the successor ant to follow this path. And if you look at the entire, means the way they work, they will able to find the solution. Now, There's one simple example I have taken to make you understand how the things are working. Let's say there's a nest, that is the origin where the ant is staying, and there's a food. And if there's a straight path, the ant starts searching for the food, and they may reach to their destination straightforward. So there is no obstruction here. If you look to the second image, so here we have one obstacle here between the nest and the food. So now there are two possible ways. One is ant can go to the upper path and otherwise the lower path. We can easily see that the upper path is actually the shorter path than the lower path. Ants have no information how to reach to the food, so initially they move randomly. They can go in both the direction, but while moving to search the food, they are leaving the traces. We are calling a pheromone. And the ant has a property, they like to move to the path where there has denser pheromones. So after a period of time, it is observed that the pheromone which is laid on the shorter path becomes more denser, means the concentration will be getting denser, which is at the shorter path. But at the longer path, if you look, because the path is longer and the pheromones are getting evaporated over a period of time, so the rate of getting evaporation of this path is faster. After some time, you will observe that because the path is shorter and ants keep on coming, so the rate of evaporation of this pheromone will be less compared to the down path. So there will be no pheromone existing, because after some time all the ants will follow the shorter path, and actually they have find the shortest path without any information. Now this is an excellent thing which can be used to find the shortest path. We have a problem that is called traveling salesman problem, where one person is to start from one city. There are n numbers of cities. He has to visit all the cities in such a way so that he can cover entire city back to the origin in the minimum time. So we are looking for the shortest path. So this can be used. So it seems like it's very straightforward. It is very useful, but again we have some challenges. Yes, it is true that this ACO can be used for dynamic applications, but its implementation is not straightforward. We need to think on some aspect like the pheromone, how we are going to represent this pheromone, how you are going to represent mathematically the rate of evaporation. In the entire process, we are doing two loops. One is the ant has to reach from the source to destination, and then how many times we need to see this process to get the final solution. So there are many issues are there, but we understood that this is possible. So if you are able to represent the natural phenomena in terms of mathematical equations, we can get excellent results. Now I want to focus on TLBO, that is the teaching learning based optimization technique, which is recently very much used in many of the problems. So far we have seen that nature has inspiring us with the physical designs. There are so many designs existing in the present world which has got inspirations from the nature. We have seen that nature is inspiring us with their behavior of the natural creatures like ants, bees, birds, flies. Nature is also inspiring us through the social phenomena that exist in nature. This is the example which got inspiration from the social phenomena. What does it mean? This TLBO is getting inspired from the principle of teaching learning. So in the teaching learning process, initially all are learners. We all start learning from the environment, and the one who gets the maximum knowledge is said to be a teacher. So we are assuming the teacher is something which is having means he is the most intelligent person. So he will learn from the system. The one who gets the maximum knowledge becomes the teacher. And then this process keep on going, because learning is a continuous process. Then teacher, again as a learner, keep on learning, and this process keeps on revolving. Once teachers gets the absolute knowledge, then the process will stop. Or you can say, if you are applying this kind of scenario in a real problem, and once you get the optimal solution, you have to stop at that point. So here, if you want to apply this to any of the real world problem, you must have some design, you must have some objective function, you must have certain goals. Your function must be of maximizing or of minimizing nature. Now this problem is very suitable for open-ended problem, where we have many feasible solutions are possible. Actually, we are aware about the solution. Like when we talk of traveling salesman problem, we know all the possible routes, but our objective is to come up with the best solution, the optimal solution. So such a space refers to the feasible solution. Optimization method. So here in this process, we keep on doing iteration for the best solution by using this teaching learning process. And we may have some design variable as well. So we'll see how all these things will combine together to solve any problems. We'll see. So first understand why this technique has been evolved and why it is so much useful. If you talk about population-based algorithm, they have two categories. One is evolutionary-based and the other is swarm intelligence-based. And they are probabilistic in nature. They need some common controlling parameters to get the solution. Along with the common controlling parameters, they also need some algorithmic specific parameters. So if you talk any of the algorithm, they always need some algorithmic specific parameters. And the main challenge of using these population-based algorithm is you need to do the proper tuning of these parameters because it affects the performance of the algorithm. And if we are not able to tune these parameters, then we may have a chance to struck in the local optima. There is also a chance that your computational efforts may increase. So in the previous algorithmic approach, we are dependent on these algorithmic specific parameters, which is a kind of challenges to deal with. But the beauty of this algorithm is there is no need of algorithmic specific parameters. We only need some common control parameters, that is the population size, which we are dealing with, the number of generations, that up to how much optimality you want to attain. So this is TLBO is a multi-objective optimization based problem where we need a population. So population here is the number of learners, the student. We have design variables. Design variables you may think of as subjects, and subjects offered to the student. And the possible solutions, because we need a feasible solutions. So grades of learner in each subject. So the scenario is all about teaching learning. And now we have to see that how this is applicable to solve the problem. So quality of the solution will be given by average results of learner considering all subjects. And the best solution will be the element which attains the maximum score, or we are calling as a teacher. So this algorithm runs in two phases, a teacher phase and a learner phase. So in the teacher phase, the learning is from the teacher. And in the second phase, that is called the learner phase, the individual element of the population or the student who have already attained some knowledge from the teachers, now they're in a position to attain the knowledge from the environment and also to give knowledge to their peer elements. So that is called learner phase. So in the teacher phase, the objective is the teacher tries to improve the mean result of the class for the course he is teaching. This is the objective of teacher phase. So here we are having some variables if you want to implement. So that we have M is the number of subjects that is offered. So in terms of mathematically, the number of design variables x1, x2, x3. So here we are saying that number of courses which are offered to the student will be the design variables. M is the population, that is the number of learners or the number of students. And Mij refers to the mean result of the learner in a particular subject J at any iteration I. K best is basically the best learner which attains the the maximum result out of the first phase. So this is the key idea of getting the solution. So in this, what we are doing, we are actually finding the difference between the existing mean result of each subject and the corresponding result of the teacher for each subject. So if you look at this formula, that is actually provides a training to the student or the training to the learner, training to the element of the population. So here you can find Ri is a random number because we see that in the real world problem we have random data. So this is to match with the real problems. This Ri is used that involves randomness. TF is a teaching factor whose value is 1 and 2, and this can be chosen with equal probability using this formula. So once you find this value, these values are added to the previous value, and then with the new value, you have to find the result. If the result of the objective function is going to improve, then we consider this change, otherwise we will not consider it. Then comes the learner phase. So in the first phase, teacher phase, we have used that formula, got the new value, and this value, if it improves the overall objective function, we keep it, and then we move to the next phase, that is the learner phase. So here, the learning is happening by the interaction between the two peers, or the two elements of the population. So this is how the algorithm is there. I'll just give you the basic idea. So the learning is only possible when two people communicate with difference in knowledge. Then only one can pass his knowledge to the other. So we have to select two learners whose values must be different. And then we check that if the objective function of first learner is less than the second learner, then second learner will transfer his knowledge to the first knowledge, to the first learner. So this is how this can be achieved. And this is the end of the second phase. So what is the observation? I have tested in many scenarios, and we have found when you once pass through the teaching phase, learning phase means your first iteration is over, you will get the improvement in the result. This may be not the optimal. So you have to decide that you want the optimal result or you are satisfied with some improvement. So it depends that how many iterations actually you are ready for, because this may require 5 iterations or 10 iterations. So how you find that the result is optimal now? If 2 successive iterations are not going to change the value of the objective function, that means you get the best solution. So if you look at the features, the best part is there is no need of any algorithmic specific parameters to run this algorithm. It's easy and specific because the idea is straightforward. It's based on teaching learning methods. Lower number of iterations are there. That's the best part, and it's speed up the process, because in the learning phase, each individual learners is interacting with each other, and this involves a kind of amortization in the process. So overall, the process will become fast. And it can be applied to many problems, like if you want to find the optimal way of combining the services in a dynamic environment, or you can say optimal service composition for on-demand system. This is very good approach. You can do the estimation of reliability parameters by using this. You can use it for decision making in a multi-criteria problems. So these are the different areas where you can apply. So this is all about the idea of TLBO. So in the present form, if you look at this algorithm, this is a fantastic algorithm, but still I feel that many of the dimensions have not yet extracted. We can do more in this. You can search for a newer dimension in this approach, like there may be a one teacher teaching many courses, okay? Or you can apply different credit to each courses. So these are different variation, different criteria that you can incorporate in this present form to make it more smarter and applicable in different scenarios. That's also possible. That's up to you, that how much you can understand this and how you are able to apply this kind of scenario to the real world problems. So in conclusion, I want to make a question that can't we make a principle that to solve any problem, we'll look into the nature's approach. So generally, if you want to solve a problem, we start with the problem statement, and then we end with the solution. But in the natural phenomena, first you have to look at how the nature is behaving, and then we have to match that how this phenomena can be used to solve our problem. So once you have realized that nature has giving many phenomena which are actually very much creative, you can readily able to apply these techniques. And applying these nature-based techniques is kind of creative things. Means when you go for this kind of approach, there is a requirement of analogical thinking. You have the capability to do the map from biological to technical. You must have an understanding of natural processes, the biological processes, and then you must be able to map this into the technical aspects which you are looking for. It also needs a visual thinking. You must be able to visualize the phenomena which is existing in the nature, and then you have to relate these phenomena to solve your problem which is having in your hand or which you are interested to solve. It also involves the meta thinking, that is called thinking about thinking. We are not only interested to design the system, but actually we are looking to design the process. The main challenge of this kind of approach is you need to understand the biological phenomena, and the challenging part is you must able to relate mathematically that this biological phenomena is actually very efficient to solve a particular problem, but how can I mathematically represent to get my work done? So you can see that there are a lot of changes are happening in computer science, but if we change the way we take the things, if you look at the natures and then start thinking to solve the problems, we can get fantastic results. So this is all I want to say to you. Thank you very much.
Thank you for your presentation. Could you explain and clarify what's the artificial immune system?
Artificial immune system?
Yeah.
Yeah. So actually, you know what is immune system?
Immune system.
Yeah. You know what is immune system?
Yeah, I know.
Yeah. So what we are doing, we actually get the inspiration from the nature, and then we have tried to map the entire process into the mathematical systems, and then we make it better to act as an artificial way. So, are you getting this part?
Sorry?
Are you getting this? What we have tried is we have tried to convert the actual immune system into the mathematical format. So when we talk about the immune system, we talk about the inertia and weight.
Okay, I got it.
Okay, so inertia and weight. So at the inertia, if you have remember, we talk about the weighing factor. So if you give me a time, I have the slide, I can show you mathematically that how we can convert this system to artificially fix in the artificial immune system. So what we are doing, we have an approach where we are converting all these techniques into the mathematical representation and then applying it to it.
Okay, I see. Thank you.
Okay.
We have only one lady speaker today. She will be talking about her topic now.
Hello, everyone. I'm Emma. I came here from Poland, and I would like to explain cyber threats in IT world. I chose this topic because, so this is about me. I'm Emma Kocik. I'm IT specialist for the last 7 years. I used to work for a telecommunications company in Poland. My former employer was ISP, so we were also internet service provider. My job, except for being IT specialist, was also providing IT security awareness for all our all our workers, new employees, and all the departments. If you want to connect with me, I know that some of you are students, you don't really use LinkedIn, so you can also find me in Facebook if you have any further questions after the presentation. So the first thing you have to realize when you think about the security in IT is that security is not a product, it's a process. So basically what we have is this ring. It always goes like this. So it's like never-ending process. It's not my idea. Bruce Schneier, as you see here, he's the very famous IT security writer and specialist. He came up with that idea, and nowadays, if you Google security as a process, you will see all the range of these circular representations, and it started with his idea. So why we consider security a process, not a product? It's because the reality is always changing. So when we secure our systems or networks or whatever, or our computers, it's not that it's the end. Then after we finish securing our systems or computers, then we have to test if it actually took any process, if it's working. If we find there is something to improve, then we improve, then we still monitor. Because if we have a breach, which I have here, so if something happens, there is some kind of vulnerability and some people may access our computers or networks. So we have a security breach, we call it. Then we have to start over. So then we secure again, test, improve, and monitor. So this is actually a never-ending process. So when it comes to IT threats, we have this concept of vulnerabilities. So vulnerability is actually the weak point in our IT systems, products. It may grow up from no updates, no encryption used in our systems or computers. Maybe we are not very careful users and we can find this kind of or any kind of meme in the internet and just click it. We click it and maybe a virus can be downloaded to our system, to our computer, and make a lot of damage. The other thing is that we sometimes may get infected email with infected link or maybe infected attachment. We open it and also we get hacked. Some virus may spread in our network. A lot of things may happen. I will explain that also afterwards. The other thing is weak passwords. So if we use weak passwords, actually we are also vulnerable in a way that someone may guess this password or just crack it in a brutal way. So yeah, and the conclusion of this one, we are never 100% hacker-proof just because of this process. So we also need to always improve our security. Remember about updates, encryption, being careful what we are clicking on the internet, and using correct passwords. I will also explain that later. So when it comes to cyber threats, I chose few of them based on reports that I've studied before. So the ones I will talk about is Internet of Things threats, because now we tend to connect many things to the internet. Using of a cloud, phishing, I will explain that later after I finish, and also ransomware and cryptojacking. So the first, Internet of Things. Internet of Things means all the things we connect to the internet. Nowadays, we don't only use computers, we use smart bulbs, smart TVs, cameras that are connected to internet. I've even seen some vacuum cleaners, gaming consoles, and smartphones. Smartphones are actually computers, just we don't really secure them as well. I don't know how many people here use antivirus on their cell phone? Yeah, there is few. Okay, you should do that, because it's also a computer. So what happens with this Internet of Things? When we connect our devices to the internet, they can become the gateway for attacker to get into our network and make a lot of problems. I will tell one example of this one. In Poland, I think it was 3 years ago now for Christmas, we had a very young and brave engineer. He decided to build an intelligent home. So basically what he did, he connected some smart bulbs to the internet. He also put IP camera in front of his house, and he said on the internet, he posted it on internet, if you're a hacker, if you can hack my bulbs, you can make patterns on my home, and you can see some patterns because you can control it with internet. So what happens after? What can go wrong? Well, yes, after a few minutes, his smart house was actually hacked. Lights were lighting up and down again, and after few more minutes, it started burning. At least someone is watching everything with the camera he installed in front of the house, and they sent him fire brigade. So nothing really happened, but if they could do this just remotely, using only the bulbs that they were connected to the internet, you can imagine what may happen if nobody was there watching this. Okay, so the next IT threat is actually use of a clouds. Well, I wouldn't say that it's bad to use a cloud, but we should be really careful with using them. And now, IT scientists, they tend to say that data is our new oil. You are probably in a mining, so we also have data mining. It's basically collecting all the data from the internet, and then there are huge databases which are also located in clouds, so they are not physical computers, they are just located everywhere. And then the threat in this model is that this data is actually not in our computer, not in device that is in our server room or in our storage. It's somewhere on the internet, and then when it's sent to the internet, it can be actually gained from the internet. Maybe if we don't secure it before we send it, maybe someone can get the access, and we wouldn't want it, because maybe we keep their data that they are not for the public. So yes, if we send something to the internet, if our password gets compromised, we should always be sure that the data we send, if it becomes public for any reason, it may be programmers or the cloud provider mistake, and then this data is public if it threats us in any way. Okay. The next thing I wanted to mention is phishing. It's not about actually phishing. Well, it is in some way, because then we are the fish. And hackers or cyber criminals, they are trying to get our identity. So maybe they try to steal our passwords, data. in order to do that, they may be sending false messages, such as emails, text, and link messages to our phones or any of the internet communicators in order to steal our password and login and then access our data. Sometimes they may use it just to threat us, try to get some money from us for not revealing some data, which again you may try to keep secret. Okay, so also phishing leads to spreading computer viruses. Sometimes email message or a link sent by an attacker can lead to spreading computer virus in our network. Then infecting and taking over more computers connected to our network. So not only one computer, we may end up with problem in whole company, in our house or organization. Another threat which I found very popular, especially I deal with that a lot at work, ransomware. Ransomware basically restricts user from accessing his or her own data. So it locks the screen, it can encrypt the data on a computer or even cloud, and also asks for ransom. So asks for money from us to access our own data. So maybe you've ever seen this kind of things. It's a ransomware which locks computer. It says to be Department of Justice, whatever, but it's actually a ransomware that locks computer and then asks for money for the fine in this, but it's a false. So some cyber criminals were trying to get some money from users this way. This is another one. This was very common last year. It was called WannaCry. This ransomware was encrypting all the files on the computer, also connected remote network disks. So this one was really bad. It would completely lock out and encrypt all the files. It was for quite a while impossible to restore the data. So in this situation, someone who has really important data in their computer and gets infected with WannaCry cannot actually access their own data. And therefore, there is no decryption. They also asked to send some Bitcoin. It was quite famous ransomware. So yes, this was the last years, and now we have this tendency to turn into ransomware into cryptojacking. So cryptojacking is it works a bit different, but it also leads for cyber criminals to get money from bitcoins or cryptocurrencies. This one installs malicious software or just implements malicious script on a website, and then someone who's accessing this website gets infected, or maybe not infected, installs or starts running cryptocurrency miner. So the miner starts using resources of our computer in order to mine cryptocurrency, which is not for us, it's for some criminal who is using our computer in order to get some money out of it. So it may happen in a few ways. First is malicious software, which can be downloaded from fake websites. Like, we can try to download something else, but somehow we get this malicious software. Then the other one is unintended installation of fake mobile applications. If you follow the news of the cryptojacking, you will realize there was a lot of apps in Google Store. Actually, after installing them, they would work like this. They were actually mining cryptocurrency for some attackers. And yeah, that's how it works. It's utilizing our computer to work for somebody else. So now the conclusions, how to stay safe among all these threats. First of all, you should always try to be up to date with your computer, with your network, with your software. Always test and always make sure you are up to date. And if there is security or important security update, always try to be the first to install it. Don't wait until you see maybe one day you will enter some website and you will see you need to download update in order to be safe. And maybe when you click that, you will be actually downloading some malicious file. So to avoid that, it's better to update just as fast as possible. So if you can use the automatic updates, it's always good to turn it on. The second thing, don't click all the links emailed to you, especially if you don't know the person who sent the email. Or you can always contact with other media and ask if this person actually sent you this email, because sometimes attackers, they try to impersonate someone else, spreading news, and then if you click a link, you may get infected. The next thing, using good passwords. By this, we have it here. We can consider it's more than 8 letters, digits, characters. So it's not only letters in your passwords. You can also use the capitals and regular letters. Don't reuse passwords. So if you have just one password for few services or for your computer, then network, it's not a good idea. Of course, change them from time to time. It's not that we should have just one password all our life. We should change them from time to time. And of course, keep them secret. Just don't tell other people what kind of passwords you use, because you never know who you are talking to. Also, it's good to be aware of all these threats. So there are several websites that can teach you how to stay safe on the internet. I don't know any local one for you, but there are some international ones. So you can maybe just try how to Google how to stay safe and then follow the instructions there. Oh, it stopped working. Yes. Okay, so thank you very much. Thank you. This is my full name. If you don't use LinkedIn, you can also contact me with Facebook. I can send you some links that you can follow the news in order to stay safe on the internet. Thank you.
We'll be talking about his topic.
Thank you. Hi. First of all, I want to thank Enver and organizers of this event for giving me a chance to make a speech here. It's a great honor, and I'm also glad to see so many young people here want to learn about engineering. They are studying engineering and they want to learn more, and it's make me proud of the people. And today I will talk about Flutter. My name is Siraj Hasanov. I am currently working as software developer in Azercell, and I'm also co-founder of company Remote Grab. And today I want to talk about Flutter. It's a new technology, and I thought it will be very interesting for many of you. First of all, I want to give you a small introduction to history of mobile development, where it started. First generation of mobile apps were designed by manufacturers. You all know this, old phones, which is very big and not so comfortable to use. They had their own software, and they developed their software for these devices. But mostly, as these systems, their devices, handsets was closed, their systems was closed. Mostly, the manufacturers of these handsets, devices, was responsible for creating software for these products. But then customers pushed the manufacturers to develop more and more features for these devices. Firstly, there was just utility functions or some games, but customers needed more. And that's when manufacturers started creating some SDK, software development kits, some frameworks, to make it easy for other developers or for community to create these amazing products for these handsets. One of the first ones, one of the most popular ones at that time was the operating system Symbian, mostly used by Nokia. You are maybe familiar with this. This software, this platform was very popular at that time. In 2009, there was 250 million devices running on Symbian. And of course, it's mostly used by Nokia. And it had its own store called Ovi Store. Customers just can download this software from different developers, different companies, and it made life a little bit easier for users. And of course, there is Android, which is currently 75% of all devices in the world. All smartphones in the world are based on Android. Its programming language is Java, and now it officially supports Kotlin, so it's now the official language of this operating system is Kotlin. And 2008 went online their first store called Android Market, and now it's Play Store. And of course, there's another solution, it's iOS. It's now 23% of all iPhones, all devices running on iOS. It's mostly iPads, iPhones, and these devices from company Apple. There's programming languages Swift or Objective-C, and they also had their own store published in 2008 called App Store. Let's see some statistics. 1 in 5 people in the world has a smartphone. I think everybody in this room has a smartphone, and this count is currently increasing. And 85% of users prefer mobile devices. So statistics show that people mostly use mobile phones or mobile devices, smartphones for every day's needs. They are using less and less desktop applications or desktop anymore. And the average time spent on mobile devices are now much, much more than on web. Now there is 2.1 million apps in Play Store. At one point, it was 3.6 after cleanup and after some removing of some harming applications. Now its point is 2.1 million, and in App Store it's 2 million. And it shows how people need these applications, how people use, and with demand, there is a lot of such solutions. Let's talk about current situation about mobile development. There is multiple approach to develop mobile applications, and one of these is hybrid applications. Hybrid applications are, for example, there is frameworks called React Native, NativeScript, or Cordova, and other, which help to develop such platforms. They has its pros and cons. Pros is that it's mostly web-based. They develop the products. You can know just basic web skills, HTML, CSS, and JavaScript, and you can develop for mobile platforms. But it also has its disadvantages as they are using web-based systems for their mobile devices. There is proxies and bridges between your code, your application, and the system. So they are using system proxies, and then they reach the core functionality or core processors of the devices, and this creates some performance limitations. There is another solution. It's native. It's just creating applications or writing software for exactly these smartphones. For example, for Android, you develop in Java or Kotlin, and you write specifically calling APIs of the creators of Android, and these applications make great performance because you are basically running the code natively. Also, on iOS, you write the code natively. It's a great solution for most companies. They are using it, but it has also its problems or disadvantages. One of them is double work. For example, in a company, when you want to develop a product, you decide, okay, I want to target the iOS and Android platforms, and you think you need two team of developers, one for Android, then for iOS, to develop and to be in the market in the right time. But most of the time it's costly because developers, you need to pay them salary, and to manage two teams of developers, it's very hard. And most of the time they hire developers which do both. And of course, a developer cannot do two things at the same time. They develop first, for example, Android, publish it, and after developing the second approach, they develop for iOS. And it makes a lot of problems for the companies. They're developing as they are late for their deadlines, and it's hard to maintain both platforms when, for example, you develop new feature for a phone. You should develop in one platform and then another. Let's talk about Flutter. Flutter is a new approach, new solution for mobile development. It's multi-platform SDK, so it means you develop for both platforms at the same time. You write one code, it runs on Android and iOS at the same time without any tweaks, without any changes. It works natively, so performance is like native. I say like native because there is a small proxy, but it's not visible because Flutter actually using graphic engine called Skia, and this engine written native code. So basically, this engine helps to draw pixels in the screen. And Flutter is just creating solutions, creating platforms for this engine, but the iOS and Android smartphones just give the canvas to draw these pixels. And that's why code pixel by pixel write designs are in iOS and Android with high performance. One of the also great points of Flutter is that it's written, supported, and created by Google. This means a lot for companies, like, for example, Azercell. We are currently thinking about products that we can support, because when there is some products or software development kits that are created by small teams or small community, there's a chance that they will no longer support this, and it's very bad for a company's reputation because their applications need to be supported for years and years. And as this is created by Google, it's a great chance that they are currently supporting it, and they will support it in the near future. Of course, it has a fast learning curve. It's because of a language called Dart. They are using Dart language for development of these applications. Dart language is very easy language, so if you are Android developer or iOS developer and you have used Java or Swift for development, Dart will be very similar for you. And JavaScript language for web developers it will be familiar for you also, because it's also like the language syntax in JavaScript and Dart are practically the same. It's also open source, which means it's absolutely free, and the code is free online. You can just Google it, download it. create your own code. You can actually look at the code of the developers, and you can change it or modify it and create your own widgets. Flutter also has its own widgets. Actually, Flutter platform comes with built-in widgets for material and iOS devices. So it's called material widgets and Cupertino widgets. They are basically replicating the design of native applications. For material design, Android, for Cupertino for iOS devices. You can use both. You can use material design on iOS or Cupertino on Android. It doesn't matter because the underlying engine for graphic design is the same. It gives great opportunities. For example, as it's native, you can use native approaches. For example, Face ID, finger scan, location-based services, or camera usage, notifications. You can use all of them. But as it's approach not completely native, for multiple devices, you should use plugins. Flutter is written in Dart, and it has its repository for packages. Developers from Flutter team also creating great packages, and also community creating libraries for these applications. And for example, if you want to use Face ID, Android has no Face ID. You can just download one library which will support both for Android and for iOS, the same technology. And there is also a great opportunity coming. It's called Hummingbird. It's a new project of Flutter team. It's currently not in even beta. It's in development mode, but they also showed great opportunities of this new framework. It's Flutter on web and desktop. So basically, for now, you are writing applications for mobile and dev with the same code base with no hassle. So everything is easy. And now you can just port this application to web and desktop. So it's great opportunity for developers because they can learn one language and write in multiple platforms. And this is also great for companies because they can hire developers who know one language, and they can create one product, and it will also serve for other platforms. For example, for now, we are creating application. We have written in website. We have made web development for months, and now we should make this the same approach for mobile development, and we should create everything from start to mobile development. There is showcase for this is that there is many companies which are currently using, despite the fact that Flutter is very young right now, but there is also many companies which are using this. One of them is Alibaba, which is China's biggest market company. They are created their own application written in Flutter, which has more than 50 million of downloads today, and every day millions of users use these applications written in Flutter in their devices. Also, there's a Google Ads application, which are used by anybody who uses mobile application of Google. And there is not so popular in Azerbaijan applications called Apple Tree, Reflectly, Hamilton Musical, and list is growing on. We are currently also in Azercell developing an application written in Flutter. Soon it will be published, and it will be one of the first applications in Azerbaijan written in Flutter. And I hope this list will continue go on, because such platforms make it easy for developers to use, and I want to encourage you to use this platform because it will make you productive in your development. If you want some prototyping something, creating some great application, it will help you easily to be on in the first places who created this application. Thank you.
First, thank you for presentation. My question is there any difference between Project C and C++?
You mean programming language C and C++, or?
Yes, yes.
There is, yes, a lot of differences between these languages. First one was C, and then it is one of the fastest languages that we know, but it has its downsides. It's not object-oriented, and it's hard to develop. The basic functionality that user needs is not supported in C. Despite this is very popular today. C++ is some new, you can say it's new version of C, and it has its classes, it has its object-oriented approach, and it's widely used today. So both languages popular today, but C++ is a little bit easier and has more capabilities in comparison with C.
Thank you.
So first of all, thank you for coming and good presentation. So in order to use Flutter, do we have to download a new platform, or is it enough to work on Android Studio?
If you want to develop for Android only, you just need to download Flutter SDK, just zip file from the official site, and you are ready to go. But if you want to develop for iOS also, you just need Xcode, which is Mac program, and you can run there your code. But Android, if you want to read Android, it's enough.
So if we have to program in both platforms, so we have to learn new language, right?
Yes, a new language called Dart, but it's very easy. So if you're already familiar with Java, you have developed Android, it will be you can start in no time. You just will read and understand the code.
So is it similar to Java, right?
Very similar.
Yeah, thank you.
You're welcome.
Well, you all talked about like every part of IT, but nobody has ever touched to the artificial intelligence.
Mm-hmm.
So my question is for all of you, because I want to know your distinct opinions on the matter. Mm-hmm. So artificial intelligence is increasingly becoming like one of the most dominant fields in all the IT, and everything around us are becoming artificial intelligence. Mm-hmm. So in this increasing tendency, in the near future, what do you think will be the relevance of the human interaction? Like, will we need human interaction, even with artificial intelligence?
Can you specify in which field? You mean in every field or in some?
Generally, because like even right now, artificial intelligence cannot be specified. Because in medicine, we have projects that are being imported to the artificial intelligence. NVIDIA in graphical made a breakthrough in graphical rendering, if you know what I mean. Like. They made RTX Lightning on, it's like everything will be rendered by the artificial intelligence. No need to write every graphical code, no need to draw every graphical aspect right now. It's happening. So in what extent human interaction will be relevant in the near future if everything will be artificial intelligence?
It's a good question, and of course there is no completely answer for this question because we don't know in what extent will the AI part of the development will reach. But I think in the near future, the human interaction is needed, and mostly because these AI systems are not ideal and they cannot replace human. They replace human in some fields where there is routine work. So people come to work and do the same thing over and over again without any creativity, without any new interaction, you know. And in this field, they use AI, and it saves a lot of money for companies which are using AI. But in works where there is a lot of creativity, when the fields where you need to create new ideas, which is not already exist in the world, human interaction is needed. And also human interaction is needed for creating AI systems, because these systems need to be improved. Current systems cannot improve themselves. They are currently working on these AI systems which write AI systems, but it's not perfect. So in near future, there will be a great need for human interaction.
Thank you very much.
I want to add into this. So what I feel is there will always be a need of this human interaction. Now, why we came up with the AI? Actually, it was being realized that the human mind is the excellent. It can do excellent task. With the traditional computers, you can do like routine tasks. They don't have the capability to come up with the new decisions. This idea comes to come up with the AI. So in the AI, if you look about the machine learning, deep learning, these are all the branches of artificial intelligence. Like she has asked that what is the artificial immune intelligence? So what we are doing with the artificial intelligence, actually we have understood the natural behavior, and then we have tried to implement this natural behavior with the computing power. Like our immune system, they know how to learn with this all these toxic activities. So we want to come up with this computational efficiency. We want to make a rule base, a database. We want to train this data so that it can work as our mind work. This is the need of AI. But it will never, ever will be the situation but that AI will overpower this human brain. Because again, we have some limitations. Yeah, are you getting this?
Yeah, but you know, I personally believe that computing power of, for example, quantum computers are being introduced right now. There are research on that. So their computing power will be, I believe, much higher than the brain, human brain, because even our memory doesn't work like the computer. A computer can memorize pretty much anything, but anything we put into it. But our brain just picks the parts that needs to be memorized. So when we are trying to memorize something again, that creates some problems. It doesn't work as fast as the computer and the machine. So that's why I said.
So in terms of computational efficiency, you can say that computer is better than the human brain. But in terms of logical ability, that there the computer is still reluctant, means it's still not able to cope up with that smartness. That's why when you look at these problems, that what I have discussed, still we have not able to manage some dynamic situation with the help of computer's power. Are you getting? What I mean to say is, we have many scenarios where we have identified that this can be solved with the computer efficiency, but we are not able to implement that logical ability to the computer so far. Maybe in the future, if it is possible. So far, whatever we have researched and identified, it is not actually possible, because this logical ability comes with the many things that works in the brain. Like we have emotions. Emotions is one contributory part that gives you the logic. It tells us that what logic should behave in which situation, which is not possible to embed it in the current scenario of this computational power.
Okay, thank you very much. So the next question again comes from observations. I don't know if it's true or not, because I have seen that many IT companies in recent years, their product genius dies. So what I mean is, the thing that made that, for example, company famous, all those, how would I say, key points that they were starving targets are now dying out. They're only like concerned about the money aspect of it, it's the business aspect. Okay, in the end, every IT sector is a business, right? But still, for example, let's say, I'm just saying, some gaming companies are not introducing anything innovative right now. So in past 5 years, they're just releasing the same product over and over again in each year, just adding some little detail to it, instead of working thoroughly on one product, like making it much more excellent. So it's same thing happens in the smartphone industry too, except for the recent introduction of the foldable phones. I'm not taking it. But still, most of the phones are going for that tendency. And right now, when the people are going to, they are making any product, when thinking the product, like IT enthusiasts, the first thing they're targeting is the money. Like, okay, the product is good, but will I get money from this? But do you think, what do you think is the cause of such thing? Like, why people are now money-oriented rather than creativity?
It's because of economy. Everybody needs money. If you have a company, there is maybe one person in shareholder community who thinks about a company, for example, but most of the time, there are people that have changed, companies sold out, or maybe the first one person, for example, who created the company, who had the passion to create some gain, is already not there. There's some community shareholders which will decide, okay, now this company has 8 million customers, let's make them bring money. So if they create some feature and they say, okay, we have some increase in revenue, so let's make further investment in this side because we had money. They don't think about, okay, we have this, let's stop and make another thing. So they think, okay, this brings money, let's continue. But it's just business, that's how it works. So
yeah, but
good
10
people,
or 15 years ago it wasn't like this, but not in this much extent things were happening. Like
sorry?
Like I say, you said, okay, it's business. It's always been a business throughout the human history, okay? But 10 or 15 years ago, such tendency wasn't such widespread.
10 years ago, it was a little bit or maybe much more easier to create new innovations because there was boom of IT, boom of technology. They came up with new ideas every day, but it's really difficult today to create new ideas and new products. It's, you know, today you see startups which are basically repeating each other. So they don't create anything new. If you just Google it, just Play Store, there is nothing new. And the smartphones, the same thing. They create some camera and they double it and triple it because it's what people interested about, new camera. They don't think about something which will save humanity but not bring money. No, it's always business. And these innovations which make people buy these products are what they are interested in.
Okay, well, what I was meaning that those businessmen are interventing with the developers sometimes with their work.
Sorry.
Those businessmen sometimes are interventing with the work of the developers. Like they are forcing sometimes developers to do the things that they are not supposed to do. Actually.
Yeah, developers are want to innovate or create something new, but sometimes you just listen to business because they are the persons who decide the way of company will rise or company will develop, and they push their own rules.
Okay, thank you very much. I don't want to be kicked out from here because people are waiting for me apparently. Thank you very much.
You're welcome.
Okay. Ladies and gentlemen, now begins our last panel, namely mechanical engineering for today. We have great speakers for this topic, and I would like to invite here Professor Mengüç from Turkey and Dr. Sharul Dol from Malaysia and Mr. Ulvi Fethullayev.
Okay, good afternoon. Merhaba. Son 2 gündür bu kadar zevkli bir zaman geçirmedim. Let me go back to English again. I thank to all organizers, I thank to all of you making this beautiful time. I am really amazed that I could feel that much at home here. With so many mechanical engineering students, and one of the things that was surprising me, there was so much enthusiasm. So indeed, this fits very well to the theme of my presentation. I will tell you about mechanical engineering, but the most important thing, I'm not just going to talk about what mechanical engineers do or what they should be doing, but I will tell you a personal story of what I have done. I was about your age when I graduated from mechanical engineering. Since then, the things that I have done was surprising. This morning, Dr. Barabas mentioned mining engineering is very important. I agree with him that everything should come out of earth and they should mine this very carefully. But then the mechanical engineers do everything around you. So all of the departments, all of the disciplines are important, and I am emphasizing that they should work together now. But now I'll get into the mechanical engineering and I'll give you a personal story. First of all, it's radiation transfer. It is not nuclear radiation, it's heat transfer. Heat transfer is one of the two important areas in mechanical engineering. Heat, you process, and then of course mechanical systems. Usually mechanical engineering disciplines divided between thermal science and mechanical systems. And among the thermal systems, you have conduction, convection, and radiation. Of course, there's boiling as well. That's the radiation transfer I'm talking about. It's light. And light has been my passion all my life. I enjoy light, I enjoy photography, I enjoy lasers, and I enjoy all kinds of things that light do, or derivative of light do. So that's what I'm going to talk about. This photograph is not that clear because of the light, but you must see the light. It's Istanbul. I came to Istanbul about 10 years ago after living half of my life in the United States. So in this graphic, I'll show you that I left University of Kentucky back in 2008. And I had a major laboratory there, radiation transfer laboratory. I will tell you some of the research that came out of that. And then I moved to Özyeğin University as one of the founding members of the university. I started the mechanical engineering program there from zero. There were no students, no faculty members, no library, no building, no program at all. And then, since then, mechanical engineering became a very nice department, one of the best in Turkey. And then we established the Center for Energy, Environment, and Economy. Whatever you do, you must start with passion. You must have an overreaching goal in life. And one of the biggest concerns we have is the climate change, of course. Now, you can ask what's going on with the climate change and mechanical engineer. Almost everything we do, if we use the resources efficiently, effectively, you become a good engineer and you can fight against all kinds of problems. And of course, climate change is a huge problem. It cannot be solved overnight, but this is one of the issues. What can you do with that? You can decrease the density of energy used per person. That means you have to be a very good engineer to do whatever you do with less energy, less fuel, less materials, less resources, less time. Show yourself, show your smartness. Decrease the time, resource, and everything so you can come out with better world. This picture, I'm not sure if you see it clearly, but it shows one of the problems. When you burn things, you pollute. But we have to burn, otherwise we cannot have the light, or we cannot have my sound coming to you. Yet you can ask the question, do we need this much light, or do we need this much material? Well, if I look at the previous slide, then if I try to understand what's going on, I must get into the science of everything. Science is the most critical. So if you are studying any discipline, first you have to get into the science, mathematics, physics, chemistry, and then combination of this, dynamics, controls, mechanics, artificial intelligence, and go on, networks. When I look at the atmosphere, when I see what happens to sun when it arrives to Earth, there's a very thin layer of atmosphere, and everything takes place there. You see all kinds of heat transfer mechanisms and atmospheric interactions of the light with the particles and so on. So you have to understand, and they are all part of radiation transfer. One thing was not mentioned, and most of the atmospheric science literature talk about everything else, but then there are buildings. The buildings and the cities we built over the years make the life more complicated. So you have to understand also what happens to the buildings. So with this idea, again, you can get into the details. I'll show you these slides very rapidly because I have several slides, and I would like to ask you, please warn me 5 minutes before it's over so I can stop. Otherwise, I can talk like hours. But when you get into the heat transfer or the details of chemistry, you can quantify. All these numbers require that you have to make some measurements. So measurements, understanding, interpretation, and then now big data, the artificial intelligence, neural networks, augmented reality, all of these will help you to understand all these physical phenomena so you can really improve your skills. Then what happens? Probably many of you know, I'm not sure if you can read this one, but this shows what type of energy resources are available on this site and where we use them. Let me explain to you a little bit simpler. This side, you have coal, petroleum, natural gas, solar energy, wind energy, and everything. Being in Baku, in Azerbaijan, you can imagine too, there's about 50%, 60% of all energy we use all over the world come from the fossil fuels, and of course from Azerbaijan. All of them are mined. Coal is mined. Will they change? No. In the next 30, 40, 50 years, it's not going to change much. Maybe sun will be like 10%, 20%, but that's it. Most of it will stay here. So, if you are going to make an impact on climate change and other things, you have to minimize their use. We cannot give up from these things, but we use them for buildings, for transportation, for industry, and for agriculture. Buildings, industry, and transportation each take about 30% each, and then 10% is left to the agriculture. So I need to do something about this part. So when you do it, you just focus on your objective. So you have to come out with, again, the goal. So in this case, we looked at the production mechanisms, which is part of the mechanical engineering. We also try to understand how we can minimize the use with efficient cars, efficient buildings, and the industrial systems. With this idea, we established the center. In the middle of this, you see the climate change and living with nature in harmony. And to be able to do that, you have to come out with really scientific research, and all these small areas are funded research topics in the center. And most of it is related to radiation transfer. And if you get into details, you have to look at energy harvesting, buildings, industrial applications, and the cities to make the cities more livable and so on. Look at this picture and think about, and mechanical engineering is telling this to you. When you think about typical mechanical engineering, you may not hear any of these things. But I feel like I can contribute to all of them. So that's the reason, in addition to Dr. Barbas, I'm insisting that mechanical engineers are also the mother of all engineers. He was claiming mining engineering is the case. So you can do lots of things with mechanical engineering. Of course, you have to work together with all other disciplines. When I came to Istanbul 10 years ago, there was nothing, as I mentioned to you. Our team is now like this. We had several of them graduated, but we have more than 20, 25 people. We had several European Union grants, and FP7, Horizon 2020, and Turkish grants. It's a very active program. Let me start. I said that we have to start from fundamentals. Now I'll go fast. When you look at radiation transfer, you look at the energy exchange between a hot object and a cold object. From hot object to cold object, the light moves. energy moves. It's thermodynamics. It's a matter of understanding thermodynamics, which is essential for mechanical engineering as well. There, you need to look at the different parts, how the light interacts with anything. When you start from there, you find out that these ideas are not new. I insist that I keep telling this to myself as well as to my students. We are not the smartest people on earth. We always find somebody else who have done lots of good things. When I say the exchange of energy between anything, and if you go back, one of the amazing guys is the Archimedes. Archimedes, he lived in Sicily about 2,200 years ago, and he used the idea of solar light to burn the ships of a Persian navy. At that time, he put the mirrors on the shore, he aligned them, and everything came onto the ship, and he burned. It's understanding how the light is transferred. I'm not going to talk about others, but when you start this, you have to go to understanding of the fundamental relationships. It requires mathematics. Then a little bit deeper mathematics. You combine all of them to come to the concentrating solar power systems. We discuss many of these ideas in a book. This is one of the books that I co-authored on radiation heat transfer. It is one of the best known books in the world. So we discuss all these things. Once you start from there, you try to understand why something emits energy, so why something else absorbs energy. The fundamentals of this is also given by another big guy. He is Planck. Planck is a German guy. When he came out with this correlation, how he can understand the emission from radiation and then absorption, eventually he led the way to open the quantum mechanics. This goes to quantum mechanics. I'm not going to get into details of it, but it is, again, the theory of heat radiation, and the Planck constant is well known now. If you continue, it's not over yet. So it's not just two expressions or a couple of calculations. You have to look at the spectral effects, directional effects, temporal effects, coherent effects, all of these. The books are a lot. So the reason I show these slides, there will be a few more of these, that you will never be done with your studies. You should continue learning more. More information is available there. And the science requires you to get into depth of all these analyses. There are several books. If we look at how we impact the industry with this know-how, we can look at some of the things. This is one of the work that we have done a long time ago to understand the coal combustion in a furnace. The coal-fired burners, power plants are very expensive. They are very, very difficult, intricate systems, and they burn coal inefficiently. So if you understand science, you can do something about it. So it's a huge system. There, you have to solve the radiative transfer equation. After that, you can look at all other things. You can apply the radiation transfer to other industrial processes. You can understand how the glass is made, how you can handle the transportation of energy, how you can minimize the systems that's used. And then you can apply this continuously to any kind of system. And one of the techniques I mentioned here is the Monte Carlo. Suddenly, I go from physics to mathematics. And this is the bottom line in science, in mechanical engineering, or in any discipline. You have to give emphasis on the physics. Physics is the key, because that allows you to read the nature. And then you go to the mathematics to simulate it. The computational tools to simulate it faster. Then you have to go back to physics to see if you understood what's going on. And then to speed up, that's what we are using now. We are integrating Monte Carlo with the hardware to make it faster and faster. On the other hand, when you look at coal, you have to understand how the coal behaves when it sees the light. This means you have to look at the particle properties. There are all kinds of particles like that. Each one of them is smaller than the thickness of your hair. All these things are discussed again in so many books. So this is the beauty of science. You should be going back to library or keep buying books for yourself. And this is one of the things that we studied, interaction of the particle clouds and the light. I don't know why this slide doesn't show, but we came out with the equipment. And this equipment, if you, this graphic, okay, it's not available. We got a patent with a PhD student. This is a laboratory version of it. Eventually, we built a desktop unit, and we sold it to Horiba, Japan. Horiba is one of the biggest particle characterization companies in the world, along with Malvern and a few others. And it's the first time they bought a patent from outside Japan. This was about 10 years ago. And this got an R&D 100 award. But think about it. We are measuring how these particles are behaving, or how big they are, what shape they are. But at the end, you have to come out with a machine. This is the mechanical engineering. So you have to understand how the concept is supposed to work, what purpose it's going to do, work, and then you have to come out with the machine itself. If you continue now at the realm, you find out that you can reach to nanoscales. Again, nano, if you take the thickness of your, if you take a hair from your head, its thickness about 100 micrometer. If you cut it 1,000 times, you are at 100 nanometer. It's not still nanotechnology realm. You have to come to 10, 20 nanometer. So how are you going to see those things at 10, 20 nanometer? Again, there are zillions of books, not zillions, 10, 15, because this is a new area in the last 10, 15 years. But seeing those nanoparticles, indeed, we have been doing it. Probably all of you know about this. Yesterday, we were at the Carpet Museum, and they were showing those stained glass windows. All those colors come due to the different size nanoparticles being in some kind of substrate. So, depending on the shape of the particles or size of particles, you get different colors. Good. This was mixed. So the question is, if I'm a mechanical engineer, if I'm a chemical engineer, I mix them. Don't get offended with that. But if I become a better engineer, I decide what to do with the size of the particles and how I change their performance. So if I look at what's going on, for example, on a surface, if there's a particle, a nanoparticle, I look at how the light comes and interacts with that and reflect it. Or if I bring two surfaces close enough, the gap is less than 10, 20 nanometer, what will happen to that? And suddenly, you begin to hear words that almost no mechanical engineering undergraduate student hear. They are called plasmonic, phononic, photonic interactions. So suddenly, you have to think about what plasmon is. Plasmon is electron cloud. Phononic is lattice effects. So you have to understand the electron behavior and lattice behavior. If you begin to go into that, you can think about machining, which is mechanical engineering word, at nanoscale, if you use the plasmonic effects and phononic effects. This is one thing that we have done, again, with another PhD student, Eli House, about 10 years ago. We were able to melt either silver or gold particles independently. So you bring an atomic force microscopy tip on a surface when there are gold or silver particles, depending on the light or interaction, the gap distance between them, you can either melt the gold particles to each other or silver particles to each other. With this, you are able to write things. With that idea, we came out with another experimental system. Look at this. This is a beautiful machine. It worked. It is to see those 10, 20 nanoparticles on the surface of a substrate, of a glass. So again, this goes from physics to measurements and then to mechanical engineering. If you continue, then the next question you can ask, okay, if I bring these surfaces together, can I transfer energy a little bit faster? We started, well, I don't know why these slides are not showing, but when we started that, another PhD student in Kentucky, we developed the tools. It was completely computational tools. He's a professor now at the University of Utah. And recently, with another student in Turkey, and as a matter of fact, an Iranian student, she completed her PhD under me, and now she's an assistant professor at another Turkish university. And with her, we looked at the nanoparticles with the gaps, with the holes, with the bumps on top of each other. What's the use of these? When you get in there, you begin to see that similar structures, very similar structures, are available in nature, especially in morpho butterflies. These beautiful blue butterfly you see, the colors are not because of pigments, but it's because of the nanostructures it has. So using those nanostructures and making the simulations like that, we find out that at certain wavelengths, we can increase the energy transfer in order of 10 to the 10 times, or sometimes 10 to the 5 times, 100,000 times. This allows us to come out with new type of sensors or radiative cooling mechanisms. And with some of the machining, we wrote another book with another PhD student. He's from Malaysia. Now he's a professor in Kuala Lumpur. We looked at the electron beam-based manufacturing. And for that, we looked at the machines and we tried to see if we can come out with the new type of machining procedure. Just to give you an idea, and it requires, again, writing new type of codes for radiative transfer, electron transport, and sound transport. Recently, we looked at the buildings, and again, in the beginning I mentioned to you, and in Istanbul we played with the buildings a lot, but again, we found out that we are not the smartest person on earth. One of the people I admire is Vitruvius. Vitruvius is a Roman architect. He was the architect of Rome 2,000 years ago, and he had a book, 10 books on architecture. When I started reading his book, I realized that he was a mechanical engineer. Of course, at that time, there was no mechanical engineering, but everything we do is, almost everything is given in his book. So we used some of the concepts he had. The most important, and I think this applies to you, we insisted on making architects and engineers to work together. And then we continue with our work on engineering, and we use the radiation transfer to come out with the spectral effects. This is the spectrum, wavelength versus energy, and emissivity, how much it's reflected or so on, and coming out with different type of materials laden with different type of particles to change the emissivity of the building surfaces, so the buildings, even when they are exposed to sun, can cool down. Not can warm up, but can cool down. It's called radiative cooling from completely different perspective. With few other students, we look at the visual comfort. how good you can read under this light, whether you need this much light or not. Again, going back to history, this is a picture of Hagia Sophia in Istanbul. Look at how beautiful it's illuminated. And we can make the calculations now to see how much glare is available, how much intensity is available, based on the windows and artificial lighting. And we applied some of these in our buildings in the university, which made one of the university buildings the most energy efficient university building in Turkey. We applied this to 2 campuses. One of them is our campus. Look at this picture. 7 years ago, there was nothing there. There was no view. This campus was not available. Now it's the most sustainable campus, sustainable energy campus in Turkey, and most sustainable campus as well. The other one is we are building 2 football field size fields with solar concentrating power systems. This is going to be one of the largest in Europe. This is with another European Union grant. Again, thank you for listening to me. The message I give you is there's lots to do, especially when you are work as a team, when you work with other disciplines. And I liked today's team, and I mentioned to the organizers, to Anwar and everybody else who's worked with him, Anwar, Eli, and so on. This is really a great starting point. If you want to find something else about mechanical engineering or center, you can send me a note. Thank you for listening to me.
Okay, very good afternoon, or good evening, depends on the season, I guess. Assalamu alaikum. Ni hao ma. Konnichiwa. Welcome. Or so far, all the speakers have thanked the organizers for organizing this, but I think let me special thank to the audience today, which is the students, you guys themselves, because I think you guys are spending your weekend in this great hall, listening to like 5 to 6 hours of lecture. Amazing, unbelievable, okay? That reminds me actually that I used to have classes from 5 to 6:30 in the evening, where half of my students are basically sleep, or the other half pretending to listen. But you guys are still, after the lunch, still here. Amazing, amazing. My presentation today, or not really a presentation, more like a sharing session, is more on the fundamentals of jet engine and the roles of turbulence flow in aerospace propulsion. Basically that I'm be focusing more on the basics of the jet engine, if you are interested in, okay? As well as, because jet engine basically they work in a high-speed flow. Okay, so we are dealing with the supersonic or turbulence. Anyone knows what is basically turbulence flow? What is actually turbulence? Turbulence, they have many, by the way, that are definitions, but basically turbulence is we are dealing with the instability, or unstable, or stability. So what is actually instability? How do we describe instability? Anyone knows? If you have a pendulum, okay, if you don't have, just pretend this is a pendulum, a name tag. Is this a stable configuration or unstable? It's not moving, right? It's a very stable configuration. Now you move into this particular configuration. What happened then? It moves back into the stable position. The same thing here. I put like this. If move back to the stable position. So everything do not like unstable, being unstable. Okay? The same thing, for example, if you have raindrops, which are water in air. Raindrops, right? Raining. Water in air. Compared to, you have a bubble, which is gas in water.
Which one is more stable, by the way? I repeat, the raindrops is water in air, or a gas bubble, which is gas in water. Raindrops from the clouds until it reach the surface survive, right? Very stable. But gas bubble is just a few seconds. If you go driving, your oxygen, a few seconds. Very unstable. So everything's involved unstable. Imagine if you have a jet engine, high-speed flow. If you have rotating equipments, turbines, compressors, okay, supersonic conditions. It is extremely difficult measures, okay, difficult engineering applications. But I'm not going to scare you of those highly mathematical equations and so on. And also that I'm not going to argue whether that mining or mechanical is more important. So I'm here basically, as I said, to share some of the important information. In order to appreciate the applications, you really need to understand what is the history behind it. Just going through some of them. The basics of the propulsion, the jet engine, then how we can increase thrust, for example, for the supersonic, the military aircraft, or even the Concorde, okay? And what happened that if you have a supersonic conditions, then you have a shock waves, okay? That will impact the performance of the jet engine, the inlet components, and so on. And last but not least, the brief introduction on the rocket engine. As I said, I think a few days back, or not, maybe last week, I think, there was an incident about the Ethiopian airline, okay? 737, Boeing 737 MAX. Anyone knows what happened? Nobody knows, right? Nobody knows. But in fact, there was the second time, Boeing 737 MAX, okay? The second time within 5 months. Nobody knows. It can be the human errors. It can be the maintenance issue. But 737 MAX is a pretty new aircraft, okay? 2016, 2017. The latest series in Boeing 737. Or it could be the, I don't know, maybe propulsion problem. Or it could be the software, the control system, okay? No one knows. But the thing is, basically, that pretty sure is the aircraft doesn't have enough propulsion to fly forward. Simple as that, okay? That's why the nosedive and crash, okay? But it's not an easy question to be answered. If I know the answer, I'll be rich by now, by the way, so I do not know. So in fact, it's a very difficult problems. So we need to understand what's behind it, what's behind the jet engine, the principle, okay? The fundamentals behind it, how can actually that we created work from the, because jet engine has many components. It has inlet, it has compressors, combustors, turbine, and of course nozzle. In some cases, for example, Concorde, you have the afterburners. Okay, so many things happen. As I said, we need to appreciate the history. A little bit, I know history is a bit boring by the way, but okay. I think our governments, okay, our governments do realize that there's a potential of speed, okay? There's a potential of speed in turbojet engine. That's why that in war, in any wars, you need to be very quick, okay? You need to be fast, at least faster than your enemies, okay? So that you can, what? Intercept the missiles, for example, okay? The first one can go into the front lines. So, the Glossier Meteor was the 1943s, actually used engine by Rolls-Royce Welland turbojet, is the only aircraft used by the Allied forces for military advantage. That's why that perhaps that the speed bring the advantage to the Allied forces during the World War II. Then the post-war, 1950s, for example, there's a growing growth in the commercial jet engine. Then we have in North America, for example, the GE, General Electrics, or even the Pratt & Whitney. They started to dominate the jet engine market. Okay, they use the same engine for the military and also for the commercial airlines. Then we have the Avon. Okay, the Avon is basically the first Rolls-Royce engine, the first one that used the cool high-pressure turbine blades, axial compressor, basically that to generate more thrust. Britain's first supersonic fighter, 1950s, the first Britain supersonic fighter. Supersonic here means that Mach number is more than 1. Okay, Mach number is more than 1. Mostly the commercial airlines is less than sonic, around 0.8 or 0.9. Okay. Then we have the Conway, again developed by Rolls-Royce. Conway is basically that twice faster, twice more thrust, okay, compared to the Avon, the previously one. Then used by the Douglas DC-8 and also Boeing 707, the world's first bypass engine. What does it mean by the bypass engine? Bypass means that it's more like a turbofan. Some of the air is not being combusted, it's not being compressed, it's not being used for the work. Some of the air is just basically used to bypass these components to cool down the turbine blades so that more combustion can be raised, more power can be generated by that particular engine. So we have this Lockheed TriStar, Boeing 747. They use a very large turbofan, titanium fan blades, and so on, because titanium fan blades are very high resistant to temperature. You can see here the growth of the thrust for the commercial and also for the military aircraft, and also here, you can see that the growth of the turbine entry temperature. Okay, turbine entry simply is this: if you have high temperature, meaning that you can You can add more heat, more combustion properties, more power generated, more thrust. Okay, so basically the developments for the jet engine, agents for change. We have a new materials, titaniums or ceramics, because of their high resistance for the heat, and also the advancements for the CAD and CAM, computer-aided design, computer-aided manufacturing. Basically, all this process, we can save time. Okay, basically the designing, all the design process, very easy for us to alter, to modify it before we commit into production. All right, and also the advancements of FEA, finite element analysis, and also CFD, computational fluid dynamics. All of these basically we can use for simulate the stresses. Okay, flow analysis is very cheap, by the way, in terms of the physical resources, rather than we to have a very large wind tunnel, physical tools. Very easy for us now to advance the knowledge on the particular area. I think you guys need to smile a bit, I guess. You guys are too serious, by the way. Very, very serious. I know that this is a late afternoon, but you have to enjoy the moment. Okay? Enjoy the moment. It's not easy for, that this is a very historical moment, by the way. So, smile a bit. All right? The other applications we have, like even in power plants, okay? Helicopters, in marine engines, even in oil and gas applications, in aerospace, rocket science. So these requires knowledge on the propulsion, okay, and also the supersonic condition. As I said before, aerospace exploration is it's a very dangerous, by the way, and risky. It's very, very dangerous, especially in the case of the rockets. Okay, especially in the case of the rockets. Why? Why, for example, how big is the rocket? The space shuttle, how big is that? It's huge, right? Why it's huge? Because it needs to carry people. It needs to carry equipments. Satellite, for example. It needs to carry what? Their own oxidizer. The oxygen. Why? Because there's no oxygen out there. So they need to carry huge gas tanks, plus the propellant. They need to carry every single thing. Okay? That's why the instability in the rockets, for example, can cause lots of problems. For example, 1986, I'm not sure whether you were born or not, but I'm very sure that I'm less than 10 years old during that time. 1986, Challenger crash. Challenger shuttle crash, okay, because of the propulsion, the leaking, okay, killing all people, all astronauts, 7 people died during that particular day. Then we have the Columbia shuttle, 2003, Columbia shuttle, during the re-entry, disintegrated because of the high temperature, thousands of degrees Celsius. The material couldn't withstand, killing again all the astronauts. Okay? and many other incidents as well. Even the Air France, okay, Concorde. What else? 477 Air France, I think during 2000, the year of 2006 or 2009, if not mistaken, somewhere between the Brazil and Paris, okay, again crashed along the Atlantic Ocean. Now I go into a bit of the theory. But I hope that you can bear with me. But it's very easy, by the way, in terms of the, I'm not going into some of the heavy mathematics in order to appreciate this. But basically, propulsion is all on the Newton's third law. We have three laws, right, Newton's. First law, second law, and third law. The inertia, the momentum. The third law is basically, for every action, there is an equal or opposite reaction. So the idea is to create what? To create the action. How do you create the action? Action means forces, the thrust. How can you create thrust, for example? Okay? So the thrust is basically differential equations of the mv over time. But again, I'm not going to go into details of this. But at the end of it, you would have the force is basically the mass flow rate times the velocity times the difference in the pressure. So the keyword is m dot and v, the mass flow rate and the VE. VE is what? The exit velocity. The exit velocity of the nozzle. So meaning then, if you can have a very high velocity exiting from the nozzle, then is a big thrust generated. So how can you create more velocity outside the nozzle? It's a very difficult thing. That's why you need to combust, you need to compress the air, okay, combusted into very high temperature, because the velocity depends on the temperature, okay, and many other things. And some important parameters. I'm not going into this in details. I will skip this. But basically, these are the basics of the jet engine. As you're probably aware, we have the inlet here, is basically where the air comes in, okay, drawn into the, or decelerated, because you have the converging and diverging nozzle. Decelerated, so that it can go into the compressor at a very lower speed. And then we compress the air, okay, make ready for the combustion. We combust it. And then we have the turbine, expanded so that this can rotating the turbine can be rotated by the action of the mechanical work. In some cases, you have the afterburners. In some cases, after the turbine, there are some leftovers of the oxygen that can be added into fuel. We have more combustion. And then temperature rise again, and then the exit velocity can be increased. Simple as that. In some cases, in high-speed application, you don't really have mechanical equipments. You don't have a compressor. You don't have a turbine. How it works then? In which application? Imagine your jet engine doesn't have a compressor, doesn't have a turbine. Simply just the air is being sucked into the jet engine through inlet and then combust. How that is possible then? Is it amazing? This is only can be done if you have a highly supersonic flow, hypersonic, for example, where if you have a very high speed flow, the compressibility is increased. So the air is basically compressed by itself. The design of the jet engine actually that allowed this compression to take place, even without the physical compressor itself. Okay, amazing. Then you inject the fuel, ignited by itself. Okay, but people might ask, how can this aircraft work? Because in order to achieve a supersonic or hypersonic, you need to start from zero, right? How can this aircraft suddenly flowing at Mach number 5? At this moment, this particular aircraft or this particular jet engine is being attached to a bigger jet engine. So at that particular speed, this aircraft can be released, a smaller scale, okay, can be released and then operating at a high supersonic at the instant basis. All right. You have Concorde. Concorde is flying what? Mach number 2, Mach number 3. Amazing during that time. Okay, but Concorde is extremely expensive to operate. Okay, also have a sonic boom. Is I think by regulations, the noise is not that comfortable to people. I think it was ceased to operate. I think around the year of 2000 because a major accident. Concorde on the year of 2000 from Paris to New York City. Okay, during the takeoff, something happened. Hit some mechanical things, leaked the fuel system, and after that burst into flames and crash, killing all people again. So these are, as I said, Concorde or military aircraft, the supersonic jet, they have the afterburners. They have the afterburners application. Again, as I said, the velocity is depending on the temperature. You increase the temperature as high as possible. But again, as I said, what is the limitation? Is the properties of the turbine blades. Yes, you can increase, you can add more heat. You can increase the temperature, the combustion capabilities. Again, the limitation in terms of the material. This show that if you increase the temperature, then the energies of the flow increase. Okay. I'm not going into these mathematical details. Do not worry. But just my argument is, what happened then if you have afterburners? This affects the performance of the jet engine in terms of the extra thrust, in terms of the fuel consumption. Okay, fuel consumption. That's why in this graph it shows that with and without the afterburners, as you can see, 50% to 100% gain more thrust, but with the side effects of the fuel consumptions. That's why that passenger airlines such as Concorde is very expensive to operate, but luckily for the military aircraft, they operate on a supersonic basis on, not every time. That's in a certain situation, okay? Then we have the scramjet propulsions, as I said before, at a very hypersonic flow, no mechanical equipments again, just all the nozzles and converging, diverging nozzle. But the issue is, I know sometimes maybe this is beyond the knowledge in this particular level, but in case that you are interested, at the moment you introduce the supersonic flow, then there is a shock waves, okay? I think you're familiar with the word sonic boom, okay? When the aircraft flying very close to you, there's like a boom sound, okay? This basically, the boom sound is due to the generation of the shock waves. It's a very tiny layers, but the difference in the properties are significant, downstream and upstream of the shock waves. The pressure densities, the pressure properties, the densities, the temperatures are increasing very, very highly, okay? So this would affect, for example, the performance of the compressor. That's one of the reasons actually, the Air France 477, during that particular night, when they flew from Brazil, Rio de Janeiro to Paris, somewhere along the Atlantic Ocean, okay, the pitot tube gave an error. The pitot tube gave an error, okay? Pitot tube is basically that to measure the airspeed. And by the Bernoulli equation, the airspeed can be converted into the, I think the other way around. The altitude, okay, can be converted into, the speed and altitude can be related. So something happened in the pitot tube. The pilots do not know the speed of the aircraft and do not know the height of the aircraft, the altitude, okay? And the flight flying in the middle of the night. So basically then afterwards, things happen in sequence and after that crash. So basically the pressure performance, depending on the properties, the turbulence properties. At the moment you have the shock waves, the properties of the pressure varies. The stagnation properties, the mean properties, and also the turbulence properties. So basically this will affect the performance of the compressors, the inlet, And these are due to the changes in the acceleration and altitude, free stream turbulence, whether you have a calm flow or variations in the winds, the angles of the angles of attack, for example, if they have any turbulence, the clouds during the takeoff, during the landing. So this all affects the performance of the jet engine. Okay, that needs to be taken into consideration. This, as I said before, in contrast to the jet engine, the rockets, they need to bring everything by themselves. The oxidizer, the propellant can be in terms of liquid or can be in terms of the solid. They need to carry on top of the existing payload, the people, equipment, satellites, and so on. So the application is a bit more complex and a bit dangerous. So basically, the nozzle converts the thermal energy into the kinetic energy for the rocket applications. That's why that if you notice, then actually the space shuttle is not that big, but the booster is really the one that takes all the space. Okay, that's why that I think if you notice, SpaceX, the Tesla companies, they try to develop where the boosters can return back to the station. Well, Falcon Heavy is still under the research investigation, but it's very amazing and also that difficult to do. But somehow they manage, maybe around 60 or 70%, they manage to do that. Again, the aerospace propulsion is a very complex matter. It involves many components, either in fluid compressible flow, shock waves, chemistry, the combustion effects, the fuel itself, structural or the aerospace structures, the plasma formation as described by previous professor, thermodynamics and heat transfer mechanics, quantum mechanics, and also nuclear physics. Okay, so basically depending on applications, depending on whether that at what Mach number that you are operating the aircraft. So basically that determines the types of the jet engine that you require. Either the propellers, the turbo propellers, what else? Either the turbojet, either the turbofan, or even the ramjet and scramjet. Depends on types of application, but still something that any mechanical engineers, I believe, is something that could interest you. All right? That's it. Okay? With that, I end my presentation. I believe that Q&A will be...
So apparently, I am the very last speaker in this event. And I'd like to thank the organizers, I'd like to thank the attendees for being so patient and for waiting for the mechanical panel. So my topic of presentation is rotating equipment engineering. So with the presentation, I'll try to bring you closer to the oil and gas and petrochemical industry, because rotating equipment engineering is one of the major branches of mechanical engineering, which is actually quite active in oil and gas and petrochemical industry. So, we'll talk what the rotating equipment are. I'll also talk about the tasks of the rotating equipment engineer during the project phase and also during the maintenance and operation phase. And I'll briefly talk about the employment opportunities in the Azerbaijani market. So let's go ahead. What are rotating equipment? So the rotating equipment are the equipment which impart or extract energy from the fluid by moving the fluid. It could be a pump, it could be a compressor, it could be a steam turbine or gas turbine. And when we talk about the rotating equipment, then we have to actually consider four important components. These are the driver, driven machine, auxiliary equipment, and the coupling. So normally we have, in this example here, we have the electric motor as a driver, driven machine is a pump, then we have the transmission unit between the two, which is a coupling, and then we have the auxiliary equipment, which is actually, in this case, used for sealing purposes, for shaft sealing purposes. And whenever we want to troubleshoot, maintain, install, or commission a rotating equipment, we have to consider, we have to take all these four components into account. Okay? So these are the typical examples for the driven machines. The driven machines are the machines which actually impart energy into the fluid. So the pumps, compressors, blowers, decanters are the good examples for the driven machines. And then we have the drivers, which are used to drive the driven machines. And these machines are typically steam turbine, gas turbine, or diesel engine. They are meant actually to extract energy from the fluid, yeah? And of course, we have the transmission units between the driver and the driven machine. The speed increasing gearbox or speed decreasing gearbox is a good example. Then we have the clutch, which is meant to engage or disengage the driver from the driven machine. And then we have the typical couplings, yeah? And of course, as I have already mentioned, we do also have an auxiliary equipment. Auxiliary equipment are quite important for the smooth operation of a rotating machine. So this might be a lube oil unit, as you can see in this picture here. The lube oil unit is used for the lubrication purposes. It could also be used for the control oil purposes. So this is actually quite a big unit. For example, here in this case, it's for the compressor unit, which is driven by a steam turbine. It has centrifugal pumps, lube oil pumps. It has coolers. It has a lot of valves, pressure control valves, a lot of gauges, actually lube oil tank, heaters, and so on. And we do also have like the cooling unit. For example, if we want to cool the lube oil, then we have to need some auxiliary equipment. So this is another example. So what are the tasks, actually? What are the tasks of the rotating equipment engineer during the project phase and during the maintenance and operation phase? So actually, the typical project cycle in the oil and gas and petrochemical industry looks like that. It starts with a feasibility study. It's a study whether the project is really worth to study, to start with, actually. So, and then it goes ahead with front-end engineering design, and then we start the execution phase. We do the detailed engineering, we do the procurement, construction, commissioning, like pre-commissioning, commissioning, and then the plant is ready for operation. We do the performance test, production test, and then the operation and maintenance phase starts. And during the whole project, and during the operation and maintenance phase, the rotating equipment engineer is very closely involved. And how is he involved? So these are the tasks of the rotating equipment engineer during the project phase, which I have listed here. Actually, everything starts with the design, as you may know. So the rotating equipment engineer is responsible for, first of all, designing basic rotating machinery requirements, like making basic design requirements for the rotating machines on the plant. Let's say we want to build a refinery or we want to build a urea plant. So we have to, first of all, develop some general requirements. So the kind of requirements are being developed for some other equipment as well. So for the static equipment, for the instrumentation, for the electrical equipment. But the rotating equipment engineer is mainly dealing with the development of the design specifications for the rotating machinery. And once the general design specifications are defined, then we can go ahead with a detailed engineering design where we have to specify the exact parameters of the rotating machinery which we are going to utilize in our plant. It could be a centrifugal compressor, it could be a steam turbine or a gas turbine. So, and this is quite a long procedure. This is quite a time-consuming procedure. And these design documents are being developed in order to make bid requisitions in the next stage. Because once we have designed everything, once we have actually determined the design requirements, and not only the design requirements, but also some other requirements regarding work of supply of work or supply of scope, then we can actually make requisition bids to the vendor. So we have to purchase this rotating equipment. So the requisition bids are being made to the vendors, and the vendor makes like bid proposals Like they propose rotating machinery in return, and then the rotating equipment engineer must do actually technical bid evaluation. So he has to investigate all these documents. He has to see whether the rotating equipment being offered is in conformance with the standards that are mentioned in the design specifications, whether the vendor can fully provide all the scope of work and scope of supply. So, and of course, once the vendor has been selected, once the rotating equipment has been selected, then the rotating equipment engineer during the project phase can also make some workshop visits, can go to the vendor workshop and witness the performance tests and some other inspection tests. Okay, so this is an excerpt from the basic design document for the rotating machinery. Here we have it's a table of content. So let's go ahead with detailed engineering. Here we have this requisition for the centrifugal compressors. It's a table of contents, and as you can see here, we have the scope of supply, scope of work, capital spare parts. So we have to mention all these kind of things before we can make a requisition to the vendor, yeah, as a rotating equipment engineer. And this is a typical data sheet for the centrifugal compressor. We have actually some standard data sheets in the according standards. We have some standards like API standard, standards for the rotating machinery being utilized in an oil and gas industry. So, and they have their standard requisition data sheets. So this is a typical requisition data sheet for the centrifugal compressor. And before the rotating equipment engineer must fill out this document, at least partially, and send it to the vendor. And then this document must be filled out completely before we make a purchase order. Okay. So once we are done with the design, once we have purchased the equipment, we have procured everything what we need to do install on our plant. The next stage is, of course, construction. We start installing the rotating machinery on the field. And once we have installed, then the next phases are pre-commissioning and commissioning. So during the pre-commissioning and commissioning, we have some activities like alignment, erection of auxiliary equipment, some piping work, some oil flushing, some steam flushing, some turbine driver solar run, and the mechanical run tests. Okay. So this is a typical alignment procedure that we are doing. Once we have installed the rotating machinery, the driver and the driven unit, we have to make sure that the driver and the driven unit are well aligned. So for the simple turbine, it can be a one day long procedure. But for a big machine, like a big centrifugal compressor driven by a steam turbine, it could take even it could take months actually to make proper alignment, because we also have some other factors like piping and so on to be taken into account. And once we have done the alignment, we could also start doing the lube oil flushing. Actually, lube oil flushing is one of the most important activities during the commissioning stage. Let's say we have a big rotating equipment, and this big rotating equipment is being supported by the lubrication system, as I have already mentioned, which is quite a big system comprised of a lot of piping, a lube oil tank, coolers, and so on. And when we install the unit is not well cleaned, actually. So we have to make sure that the lube oil which we supply into the bearings, into the control system, into the gearboxes is very clean. So that's why we have to, first of all, clean the system, and we are using the original lube oil for the cleaning purposes. We are building a recirculation arrangement, and we are recirculating the lube oil. It could take it could take even months, actually, in order to have proper results in the end, in order to properly clean the whole lubrication cycle. And we could also use some thermal shock effects, like increasing and decreasing temperature, or air bubbling effect, in order to actually facilitate the lube oil flushing and in order to speed up the lube oil flushing procedure. And in the lube oil flushing, during the lube oil flushing, we are putting some meshes onto the return line into the lube oil tank, as you can see. And the top meshes were removed after the second flushing, whereas the bottom meshes were removed after the 15th flushing. So, and we actually, like this, we did 15 flushing recirculations, and it took like 2 weeks. And as you can see, the top meshes are quite dirty, but the bottom ones are very clean. And of course, we have some acceptance criteria regarding the size of the particles and regarding the number of the particles on the meshes before we can proceed, actually. So, and then we do the mechanical run test. It's another commissioning procedure. So once we have aligned, once we have lube oil flushed and everything is okay, we have to check whether the equipment runs smoothly without any vibration and temperature rise. So we are actually running the equipment like for 2 to 4 hours, depending on the size of the equipment, and we are taking records, actually, vibration records, temperature records, noise records, in order to ensure that the rotating equipment is well aligned, the rotating equipment runs smoothly. So these are not actually run under operating conditions, under actual operating conditions, because we haven't started up the plant yet. We might not have the proper operating pressure and temperature available to do the performance test, actually. So that's why it's just a basic mechanical run test in order to see that we have some, like the equipment runs smoothly. Okay, so once we are done with the commissioning, what is the next stage? The next stage is like the plant is ready for the operation and maintenance. And we have during the maintenance and operation stage, the rotating equipment engineer is basically responsible for the reliable operation of the rotating machinery. So we want to have rotating machines running as long as possible without any interruptions. So in order to provide for that, we have to have proper preventive, predictive maintenance techniques. We have to do proper troubleshooting, yeah. And we have to actually have some well-educated technicians, well-educated site engineers on site so that they don't make any mistake, resulting in a big trouble for the whole plant, yeah. So if we look at the lifespan of rotating equipment, we can see that if it's typically it's 30 years, the lifespan of a rotating equipment, and only the first 3 years actually is about design, manufacturing, and commissioning and performance tests. The remaining 27 years or 90% of the life cycle of a rotating machinery is about operation and maintenance. But it's quite important that during these 3 years where we have design and commissioning, you don't make any kind of design mistake. You install the equipment properly, because a mistake in this phase can cause long run troubles for the end user, because the end user would suffer from it continuously in the future if you have a mistake, if you have made any mistake here in this stage. Yeah. Okay. Typically the objectives of the end user is actually maximizing the reliability, maximizing the product throughput, and minimizing the operating costs. So let's take SOCAR ammonia urea complex as an example. At SOCAR ammonia urea complex, we have quite a lot of centrifugal pumps, and these centrifugal pumps are just like main centrifugal pumps without any standby, yeah? And if let's say a process air compressor trips there, then the whole plant will have to stop. So the urea production will stop. And so considering that the total daily production is 200 tons per day, and considering that the price for the urea is $170 per ton, and if we stop the plant for 3 days, the revenue loss for the plant would be like $1 million. So, and this kind of a trip in a centrifugal compressor might be due to unskilled maintenance of the compressor or its auxiliaries, or it could be also, of course, it could be due to the unskilled or due to some troubles in the turbine, like because the compressor itself is driven by a steam turbine. So, any kind of a small mistake could result in a big revenue loss for the whole plant. And actually, it's not only about the revenue loss, it's also about the image loss, because the client is waiting for the product. Yeah. So actually, the other important task of a rotating equipment engineer is troubleshooting. So troubleshooting is very critical. So, and in order to troubleshoot, you have some techniques. One of the most widespread techniques is our CFA analysis, root cause failure analysis, where you first define the problem, you collect data, you identify possible causal factors, and by eliminating the possible causal factors, you end up with a root cause. And then once you have found the root cause, you can start generating a solution, and then you can implement the solution, yeah? So typically the causes, the causal factors of machinery failures are the process condition changes, installation errors, operation procedures, design shortcomings, or component wear out. So I want to show you an example, a case actually, where I have, from my experience, here we have actually a steam turbine. Like it's a steam turbine of a natural gas compressor. And normally a steam turbine has an integrated governor valve. Actually, governor valve is meant to adjust the flow rate into the steam turbine depending on the load on the steam turbine. So, and the governor valve has an actuator and has a lever. And the actuator is meant to lift the valves, to control the valves here, as you can see. These are the valves. And the higher the lever is lifted by an actuator, the more the valves are lifted, and the more steam goes into the steam turbine. Okay. So here we have the typical, like, expected valve lift curve from the manuals, from the data sheet of this specific steam turbine. And here the steam flow rate is plotted against the valve lift. Yeah. As you can see. We did a turbine solo run test in order to see whether, because before we can do the MRT, mechanical run test, connect the coupling and do the mechanical run test, we have to do turbine solo run test. We have to ensure that the turbine is in a good condition. So we did a turbine solo run test, and during the test we have noticed that the valve lift was like 4 millimeters, whereas the measured flow rate was 1.5 to 1.80 tons per hour. And when we look at this diagram, we can see that the valve lift at 4 millimeters should actually generate around 4 tons per hour of flow rate. Yeah? Something was wrong, so we couldn't get enough flow rate actually. So we wouldn't be able to get the design flow rate here, because the valve lift was already 4 millimeters, and at 4 millimeters valve lift, we were getting the flow rate which we had to get at 2 millimeters valve lift, yeah? So that was an issue. So in order to solve the issue, we did a root cause failure analysis. So as I have already mentioned, the first stage in the root failure cause analysis is actually defining the problem. We defined the problem, we collected the data from the trends, from the DCS, and so on, and we listed the causal factors. What could be a root cause? What could be a possible root cause? For example, one root cause could be actually a choked flow passed by foreign material. So it could be some foreign material could be there in the somewhere between the valve and the valve seat, and it could cause the less flow rate than we expected. So in order to investigate this causal factor, we actually opened the turbine triple throttle valve and the governor valves, and made an overhaul inspection and the boroscope inspection, and we found out that there is no any foreign material there. So everything was okay. So meaning that this causal factor is actually not likely to be the root cause of this problem. And after eliminating some other causal factors, we came to the conclusion that the insufficient valve size was an issue. The valve was not chosen properly in the very beginning during the design stage. So this is a design shortcoming actually. So comparing to the steam turbines in the other plants, similar steam turbines with the same power, the valve size was actually much less than it had to be. So we had the valve size was 22 millimeters, whereas the valve size in the other steam turbines in other plants was like 28 millimeters. So this was identified as a root cause and actually as a possible, a very likely cause. And the solution was provided. The solution is actually, of course, to, because it's not, it's very costly to change the valve itself. We decided to increase the valve size and the valve seat size. So the vendor came to the site, they did some modification works, and they increased the valve size and the valve seat size. And then we did the turbo installer run again. And according to the results of the turbo installer run in the later stage, we could achieve the results that we wanted to achieve. So at 2 millimeter valve, we were already achieving 1.5 ton per hour flow rate of a steam, yeah? Okay, so I will also briefly talk about the employment opportunities in Azerbaijan. So actually, you can mainly be employed in oil and gas and petrochemical industry. Here I have listed some companies where you can work. So these are, for example, SOCAR. SOCAR has a lot of subsidiaries where you could work. SOCAR ammonia urea complex is a good example. At SOCAR, SOCAR Polymer and BP, you can work in operation and maintenance phase, basically. And then we have some companies like SOCAR KBR, SOCAR Foster-Wheeler, Wood Group, Wood Group, where you can actually be in the design stage. Like they are actually basically, they are making some front-end engineering design for the projects which are being implemented by BP and SOCAR. So you could work for those companies as well. Okay, that's all for me for today. Do you have any questions? Thanks.
Thank you very much for your presentation. Now, I'm going to invite here team leader Emil Rzaev.
I want to use that. Okay. Sorry for I'm late because I have a really hard work for this great symposium. And thanks all the guys for attending this symposium. Actually, I want to say only one word. Granny, I really did it. Please clap. Now I have a team, and I want to say the names and invite here. Firstly, Nigar, please. Mehran. Nurana. And please, aloud. Yeah! Shams. Nermin. And finally, Jehun. And I want to say it, Anwar and Mehim, please come here. Yeah, this is our team. We are working about 6 months. And what do you think about that, please?
So tired, but we really enjoyed with our guests and local speakers as well. And I think we really great network with everyone. And I think so. These students learn something from here, and we are really, really glad for that, because for the next years they will know how you just go follow their life, a kind of, as you see here, that there are a lot of the professors and the doctors as well, these academicians, and also from the industry sectors, engineers. So I think so. They will know which way they should follow in the future. And I think Emil and I cannot do anything without this great team. And I'm really, really thankful for them. And thank you so much for your participation. And I really hope so you enjoyed today. By the way, we have some hashtags from Horizon Education Agency. So, and we want to just to say something, and probably Mehin will say that.
We have members that they helped to share us, to advertise us in social media, and they made this event. And I would like to just announce them. The first one, that Khalid Hidayat, that he can use our services, I mean the Horizon Education Agency's full services, and he can just he can come and get his present.
I can also continue. So here is also Fidan Ali. I don't know, we just choose from Facebook. Maybe it's just a Facebook name. And she will also just get our services just a 50%. And we will apply for her the foreign from the Europe and as well where she want. And we have just a gift from Freiberg, Renat Novruzov. Yes, but they will get, yeah. So that's all.
Okay.
And
I want to say something new, and we have a new volunteer team, and really thank you for helping us, and thank you for participation. Really, thank you, and see you.
I think somebody, if they have the questions to our speakers, they can ask if they want. Raise your hand, and we can provide some microphone for them as well. If you have a question. Any question? Okay. Nothing else. That's all. So it's over. Thank you so much for attending, and enjoy your life. See you next symposium.